Hey guys, it's Edit Ebenezer again from Semani Enterprise Tutors, and for almost 2 to 3 tutorial videos now, we've been looking at methods, and we'll soon be bringing it to an end. I think it's remaining just 2 more, this and then 2 more. Today we're going to be looking at the return type of boolean. Okay, so I know we've not talked about boolean much since the tutorial series, but boolean is a data type that can only have two values. Okay, so a boolean tall can only be true, okay, or false. All right, I spelled that wrong. Okay guys, so today we are going to be creating a method that would take in an integer as a value, and then we determine if that value is a prime number or not. Okay, so it's going to return to the caller true or false, depending on if the number is a prime number or not. Okay, so what's a prime number? A prime number is a number that can only be divided by itself and 1. So we talk of numbers like 1, 2, 3, we talk of numbers like 5, 7, talk of numbers like 11, 13, and talk of numbers like 17, 19, 23, I presume. Okay, so we're going to first of all have an integer value or int variable called number, and then we're just going to declare it. So we're going to be needing a scanner. Okay, so by now I shouldn't be explaining what we need a scanner for. We need it to accept value from the user now from the console. Okay, so scanner system.in. okay, so we then say number is equals to scanner.next int. All right, so what we want to do is we want to create a method called public static. Now instead of void or int or char as we've learned, it will be boolean now. So a boolean, this method is going to return either true or false. Now true or false. Okay, so we're going to say check prime, and then it's going to have an argument of since it's going to take the number as an argument. Now that means it has to be an integer or an int variable as the argument. So we're going to call this number imputed. All right, so so before I go further, before I started this tutorial, I created a Java class that I called boolean return type.java. okay, so you can do that and join us. All right, so now what does it take for a number to be prime? Meaning it has to only be divisible by and 1. okay, so in order for us to check that, we're going to use the common principle of checking that a number is not divisible by half of itself. Okay, so if I enter 12, we have to ensure that the number is not divisible from 2 to half of it, which is 6. So if it is divisible by from 2 to 6 without giving us a remainder, meaning the remainder is 0, that means that that number is not prime. But if that number been divided from 2 to the middle number of itself, so enter a number like 13, the mid of 13 without a remainder is 6. Yeah, 6, remainder 1, so that will be 6. So if that number is not divisible by 2 through 6, that means that number is a prime number. Okay, so what we're going to do is right now we're going to, for us to check the numbers, we're going to have a for loop. Okay, so if you've not a for loop is new to you, I will drop a link in the tutorial for you to check and then follow up. Okay, so we're going to have an integer value called int check. Remember I said number was going to be from 2 to half of that number. Okay, so we're going to check that number from 2 to half of itself. Okay, so check now. Okay, it's less than or equals to number imputed divided by 2, meaning that number imputed divided by 2 without a remainder. Okay, so check plus plus. All right, now on doing that, we would want to then check. So we would have another variable called int temp. Okay, so this temp will stand for temporal, probably just something we want to use to check the division on itself. So temp now will be equals to, now the number imputed now, so imputed number, all right, imputed number modulo I or modulo check now. Okay, so what this means is this modulo now, as I like to call it, meaning the remainder. Okay, so 13 modulo 2 would be 1, because 13 modulo 2 is 6 remainder 1, that is 6 times 2, 12 remainder 1 to make it 13. So what we are checking now is temp will be equals to the number imputed modulo check. So for the first iteration it will be, let's say I enter 12, it will be 12 modulo 2, and then 12 modulo 2 is 0, because 2 can go into 12 perfectly without giving us a remainder. Okay, all right, so that is that. Now I would then say I would check if this temp now, okay, equals to 0, that means there's no remainder. That means it perfectly, that means from 2 to half of that number, since we are looping, is if there's a perfect division, that means that number is not true. That number is not a prime number, so we're going to return false. Okay, else, all right, else return true. Okay, so let me check that. All right, I'll just write this, return false, return true. Okay, so if false is not returned, then most definitely true will be returned. Okay, so since we've checked this, we've gotten the, what was it called, now we've gotten the method to check it. Okay, so what we'll just do is say system.out.println is okay, we'll say is, I would have to concatenate this with is number and concatenate it with another string. Okay, is number a prime number, then I would concatenate it with the value being gotten from the method, and then we're going to pass in our argument of what, of number. Okay, so as simple as that. Let's run it and let's see what we get. Run as Java application. Oh, okay, sorry, in order for us to be able to tell the user what his or what application he or she is using, we're going to first send out a message, okay, and say enter a number to check for prime. All right, so I'll run that again. So enter a number to check for prime 13. Is 13 a prime number? True. Okay, so let me enter another one. 6. So 6 is definitely not a prime number. Okay, so false. Alright, so I'll go over it again for us that did not really understand how it worked. Okay, so this method is called check prime, and then it returns a boolean value back to its caller now. Okay, so check prime receives an argument of an integer argument called number imputed. Okay, so we have an integer variable called temp that is temporarily going to hold the modulo and the modulo of a particular division now. And a prime number is a number that is only divisible by itself and 1. So therefore, if that number is divisible by any number half of its number, that means that number is not prime. Okay, so what we did here was we said we initiated a for loop with check equals to 2, and check is less than or equals to the number imputed now. Perfect number now, whole number division. The difference between this division and this one is that this gives us the whole number division. So if we say 13 divided by 2, this would be 6, but 13 modulo 2, this would be 1, because 13 perfectly divided by 2 will give us 6. 6 times 2 is difference between these two. Okay, so this will be 6, then check plus plus, meaning we're going to increment the value of check being 2 to half of the number imputed now. And I said temp is equals to number imputed modulo check. Okay, so let's say I entered like this, I entered 6. The value of check would be from 2 through 6 modulo 2, or 6 divided by 2 is 3, so this would just be 2 and 3. Okay, now temp is equals to number imputed modulo check. So the first loop now, it will be 6 modulo 2, and 6 modulo 2 is equals to 3 remainder 0. And now said if temp is equals to 0, meaning that if there was a perfect division between the number and from 2 to half of its number, okay, return false, therefore that number is not a prime number. But if the temporary variable is not, the division is not 0, definitely that number is a prime number. Okay, so here we display to the user to enter a number to check for prime, and then here we now displayed it, said is number a prime, yes, true or false. Okay, so I'll run that again for us to see, run a Java application. Okay, so I'll enter another number, I guess number of 91. So definitely 91 is not prime. Okay, so you could make this application more broader and then indicate what particular number divides 9 that makes it not a prime number, meaning from half of it. Okay, so let's see if we can do that and check which number could divide it. Okay, so if temp is equals to 0, then we can now say, I can now say here that system.out.print, then I can say, okay, I can then say number imputed concatenated is divisible by check. Okay, so let's see. So we put 91 again. Alright, so 91 is divisible by 7. Okay, so let's see. Let's run with run a Java application. Let's try 1110. Okay, 110 is divisible by 2. Okay, so we can see we've made, so the program can be improved to be any other kind of program. Alright, so guys, thank you for watching. Please do come back for the next tutorial. We're still going to be dealing with methods. From our next 2 tutorials, we'll be dealing with methods, and I hope you're learning. Please do continue your hands-on and keep learning and keep practicing. Okay, God bless you.